as I was saying, but most of you missed my iPad. I don't know what's going on. I have to ask Mrs. Christensen. Something changed, and so it's not connecting. Yeah, it's been fun. Questions?
Answers,
Problem is, Mr. Park gave me something I think similar, and it didn't connect to my computer, so I need Mrs. Christensen to do all that all over again, and so it just takes time. Why am I on your shared folder? 4K, 4 o'clock. Because the keys. Did you find it?
Yeah.
So here's the AP multiple choice you guys already have.
So
Here
I don't
is
know
the.
why wasn't there when I looked at it at English?
Sometimes.
But it was there when I looked at it in German.
Like, it was there yesterday, but I don't know, like on phones and mobile, whatnot. I have a lot of kids who are like, it's not there. I'm like, I loaded it yesterday or 2 days ago.
I keep trying to refresh. I kept trying to refresh it in English. And
I haven't found anything magical as to what, why, when. I don't know.
Just feels about
Sometimes it works and sometimes it doesn't.
Cool.
But the nice thing is we have the key here. We can go through it quickly if someone hasn't graded it. But then if you guys have questions on those of you guys that have looked at it. Oh, well then that's kind of pointless. You guys are turning in tomorrow. Let's see. It's test day, so what's going on? You're turning in your notes. Check. You're turning in your homework spiral. Check. With a review? No. Instead of the review, what are you turning in? The packet into the tray by the end of the day. Huh?
This packet.
Yes, that packet. Now, what else is chilling in here, though, for Chapter 10?
I put the lines.
Okay, sick. So, in your shared folder, there is a key for the FRQs. Which FRQs? The ones you have. Why did I give you them? In case you want to practice. How come? Because it'll be good for tomorrow, since tomorrow has FRQs.
Oh.
Now, tomorrow, there are 2 portions to the test, and I honestly cannot remember for the life of me how much time it took. So, there is a multiple choice portion, and there is an FRQ portion. The FRQ portion, there are 3 FRQs. 2 of them are required. 1 of them is bonus.
Wait, like FRQ or long answer?
FRQs. Which are long answers.
But like whole FRQs, Miss T?
So,
This is gonna be fun.
it is going to be fun. I'm going to give you guys the multiple choice portion first, and let's see how much time it takes. Tracking? Okay. Then, if you're able to finish that within like half the class period, I'll give you guys the other FRQ portion. If we're not really able to finish it, then, like if it's taking us too much time, then we'll just wait and do the FRQs on Friday.
Okay. How much do we, don't we usually get
During
like
lunch or
15?
after school tomorrow? Okay, let's hope that we finish it, and then we won't have to worry about it. So we're going to try and finish it for
Don't we
8
usually get 15 minutes per, or is it 2 minutes per? Okay, so we should have time.
theoretically.
'Cause
Because I don't think the multiple choice should take us that long. It all depends on how long the multiple choice takes you.
Okay.
Does that make sense? Because like you have half an hour plus like 15, 20 minutes, so that's about right AP timing wise. So I'll probably give you the multiple choice and the FRQs, but everyone has to start on the multiple choice first. Does that make sense? Cool. When you finish the multiple choice, just raise a hand, wave at me, and then keep going. So I can see exactly. But if no one's waved at me and it's like, I don't know, we have 10 minutes left of class, then let's not do the FRQ portion. Tracking? Okay. Have your calculator tomorrow. You don't necessarily need it for everything, but I'll let you have it nearby because it is required on some, and instead of you guys having to, I don't know, figure it out without, I'll just let you guys have it. But, so one more time, why is there FRQs, and why am I giving you an empty packet, and why am I showing you answer keys to all of them online? Because it's great practice.
So we don't have to do the chapter review?
No. I don't think did I list a chapter review online?
No.
Okay, yeah, it's empty. So no chapter review. Instead, if I were you, I would practice with FRQs and look back over the AP multiple choice that I'm not taking from you today so you can study. George?
Is both of these for the chapter review, or is it just this?
Both of them are technically for the chapter review. Joyce, look, we have a person.
Joyce?
She's going in for French, but she waved at us. Go team.
Aww.
They have to do their French practice.
This is like
something.
Inception time paradox.
Whoa, she's here and she's not. Anyway.
Alright.
Ah, we're talking about you, and you're here, but you're not going to be when you listen. That's the inception. Anyway, so, you guys know what to do. Let's go back to your Power Series multiple choice review, if I can open it. I know Amanda and maybe a few others have other questions from 10-4, yada, 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 so I have the book theoretically loading. Theoretically being the key operative word.
Joyce, rewind the video to the part where I said hi to you and say hi to your past self.
Please don't.
And that would be so cool.
Whoa.
I feel like this is a trick question.
Okay, what questions do we have in the AP multiple choice?
Number 15 And then
14, 18, 19, 15, 14, 15, 18, 19. Those are the ones I heard. Anything else?
I don't know how you heard the.
I put them in order. I heard.
Okay.
It was annoying out of order.
yeah, that sounds good.
Okay, 14, 15, 18, 19. All right, should we look at the answer key or look at the blank ones? What do you guys want?
Blank
Because
ones.
the answer
Okay.
key didn't.
I figured. I was just double checking. Okay, so here, and then I need to put it in your other file because my iPad's not working.
See, I have this one again.
Something must have changed with the network. I don't know what it is. I'll have to ask Mrs. Christensen. Okay, here we go. Let's do this and see if he works. Please work, because it helps if you work.
Miss D, I know you've answered this question before, but if I have like a 2 times 2/3 to the n, can I pull out a 2?
Out of the series.
Pull out a 2. You mean distribute in a 2? Oh, pull it totally out. Yes, you can. And it'd be a huge parenthesis with the whole series, right? Okay, got it. Capture new page. Let me get all of them while we're talking about it. So 14, and then 15, and then... Oh no, I'm going to cut something off. No, I'm not.
Ooh, 19 is fun.
Close enough. And then 18. Wait, looks fun. Didn't you already do it? Because you've had like days and days and days.
Oh.
For 19, it was just the conditional, or the open close interval.
Testing the endpoints.
Yeah, that.
Was it?
It's kind of the interval too, though, since the intervals are a little bit different.
Yeah.
Okay. Dun dun dun. Ta-da. Okay, got it. All right, number 14. Here we go.
That was a Space Odyssey, right?
Dun 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 dun. Yes. Dumbest movie ever. Good soundtrack. Okay. A function f has a McLaurin series given by there it is, centered at 0, right? Which of the following is an expression for f of x? Who does he look like?
E.
Oh, I thought it was. Oh,
It kind of looks like E since you have over factorials, right? So let's think about it. Hold on. Who is E? Oh dear, hold on.
This is the first time we've been using the whiteboard.
Oh yeah, you guys weren't. I've used it a couple times since I've been kind of hobbling. But probably not as much as I'm
When
answering,
you
but
stay on the board and keep your leg up, I'll do it.
Does that hurt?
I can't reach that. I'm too short.
George and I going
I like
to
you.
piggyback you. Oh,
Okay, so
that's
piggyback.
funny.
Who's E to the X?
One plus.
Okay, actually I'm giving 3 tests today, so out of all the days that iPad did not work, as long as it gets working tomorrow. Okay, he's 1 plus
X plus X squared over 2 factorial.
So it kind of looks like him, but it kind of doesn't. So what are we supposed to do?
Let's derive
It looks like he's missing some people.
Wait, Steve.
Who's over? Yes.
If you keep the derivative of that, would it just be the same thing? Curiosity.
How come? What's the derivative of E to the X's? If you integrate, guess what? It's the same thing. Whoa, mind blown. Okay, so coming back.
Yeah.
It's kind of cool to see it as a polynomial, not just as E to the X. Okay, so coming back. Focus. Who is over X? No. Who is over 2 factorial instead? X to the power of 4. So what could get plugged in to make that X to the power of 4 and that X to the power of... Oh, wait, that doesn't work? That doesn't work. Does it?
It's not E at all.
Because if it was X squared, that'd be X to the 4th, but X squared cubed wouldn't that be X to the 6th? Well, that doesn't work. What else can we do?
Times X.
So is E to the X squared a good idea?
No.
Okay. What's this one?
We're multiplying by an X squared.
If I multiply X squared times X squared, that's X to the 4th. If I multiply X squared X cubed, that's X to the 5th. Oh. Okay, so what happens if I multiply X squared? E to the X.
What about the first few?
Hold on. That'd be X cubed.
Oh, I see.
5. Who's missing?
We need to subtract X cubed to make it.
Dun, 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 dun.
Oh my
So
god.
the X cubed and the X squared are just like separate. They're not part of the McLaurin, right?
Well, they are part of the McLaurin, but can't I, this is an infinite series, can't I just subtract the other side and then get the rest of it?
Oh, okay.
Does that make sense?
I was thinking that like the minus x cubed minus x squared had to be a part of the e squared or x squared e x. Yeah, I got it in the order.
My answer would be kind of no, but it means kind of is yes. Yeah. Right.
Wouldn't a big tip off that it's not any of the trig functions?
Because it's not alternating.
Yeah.
Because even if you multiply a trig by a negative, it doesn't really matter, right? Because it's still gonna be. Now, if you plugged in a negative x, that could change things. But I don't see any negative x's being plugged in. Okay, that's number 14. Boop! Number 15. I apologize for the bad copying job. It wasn't my fault. What are all the values of p for which the infinite series, there he is, converges? There he is.
We have to, p plus 1 has to be greater than 1, right?
Is plus 1 in the power or is he down below?
Oh, I can't tell.
Struggle.
Oh,
That's
it's
not
down
so
below,
good.
I think.
Yeah,
Yeah.
it is.
So then it's p has to be greater
By nth
But what
term,
about the plus 1?
than right.
nth term it would have to be at least. It would have to be at least 1 for it to be a ratio for it to converge, right?
No, for nth term.
He couldn't be.
If it was negative 1, it would be no. If it was 0,
He couldn't be
one
less
would
than 1.
diverge.
Yeah.
So it has to be greater than 1 because if p is 0, then it would be n
Nth
over
term
n.
test, it diverges, right? Because it's infinity over 0. Is there a way that we actually set this thing up?
That's not what
Well, it can't be 1 because then nth term is
bottom with 0 that it cannot
Can't be
go
1, so the
beyond.
limit would be 1. Can't be 0, negative 1, because the limit would be infinities. Can it be just greater than 1? How about 5/4?
But that would make the bottom win.
The limit would be 0.
And then we don't have.
This is where you have the comparison test,
Mm-hmm.
which those are discussed.
5/4, so then it would be 1/4, and then that like 1 over n to the 1/4, and that diverges.
Oh, it's
No, yeah, that diverges, so it can't be equal to 2. No, that's still less than number.
1 over n squared is.
So Amanda's thinking, what if we did have the sun, yada yada yada, and then the 5/4, because that'd be greater than 1 but less than 2. You can do 3 halves if you want. You want to do 3 halves instead? The limit would be 0, yes, we know, but what would we compare it to? Couldn't we do limit comparison test to end of the 1/2, or it goes 5/4, end of the 1/4, or end of the, some sort of fractional something or others? But what's true? Limit comparison test. If we compare to end of the 5/4, or sorry, end of the 3 halves, end of the 1/2, there we go. We would have a limit of 1, but do you remember what happens with limit comparison test when the limit equals 1?
Yeah, they will have to converge.
Okay, so what do we compare it to?
To the 1/2.
So
1 over end of the 1/2 diverges, right? So we know that diverges, that doesn't help. Okay, let's try 2. What if it was n squared?
Well, you have to compare it to 1 over n
Which diverges.
and same.
That'd be n squared over n squared would be 1, so it diverges. Oh, struggle. So what if we do something a little bit greater than 2? Like end of the...
Can we do it to the 3?
No, that's not
So we can compare to 1 over n squared. The limit is 1. That's a convergent series. Simple, that's it. However, does anybody try the limit comparison test? Are we sure we're good on that?
Go ahead.
What am I checking this one?
Limit comparison test.
Or like, what am I?
When the limit equals 1, making sure what 1 does, the other does.
Yeah, that
Yep.
is what it is.
Yeah.
And if the limit is 0,
Right.
what's going on?
Limit is 0, they have to both converge or diverge.
And if the limit is infinity,
Both diverge.
Both diverge.
both be divergent. Good. Okay. Zoop, 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 zoop. So our final answer is? Yep, because it cannot equal 2 and it can't be anything less than 2. Therefore, E is the final answer. We've done some other ways, sure, but trial and error works for multiple choice, right? Number 18. Ooh, I see an alternating series. Ooh, I see. Almost a geometric. Let f be the function given by. Ooh, they even gave me the Taylor series for ln centered at x equals 1. Let f be the function given by the sum of the first three non-zero terms. The maximum value of is, the maximum value of, what's ln of x minus f of x?
Oh, that's the alternating series.
Error.
Error. Sorry, I guess let me take a
Yeah, we can do error. We could do Lagrange, technically. Or we could do alternating series. Right?
Yeah.
Like the maximum value of.
This one is a calculator one.
Ah, yes.
Well, I guess that makes sense.
Oh, yeah.
I think we use alternating series. That sounds good to me.
Mhm.
So therefore, ln of x minus f of x is defined to be the third degree polynomial. Oops, no, 1, 2, and 3. Because the first three non-zero terms. What are we plugging in?
Plug it in.
This is not complicated, just a little bit, right? What's it going to be less than?
1.7 greater than 0.3.
The actual. No, yeah, a sub n plus 1.
A sub
A sub n plus 1 should be a sub 4, right? So who's my a sub 4? Absolute value, the alternating doesn't matter, so we end up with x minus 1 to the 4th power all over 4. On the interval for x within and including 0.3 to 1.7. Alternating series test, help me out real quick. Is it less than or equal to? Is that right?
Yes.
Six
Plus
less
negative
than?
3, yeah.
Good. Question. What's going to maximize that expression? 0.3 or 1.7 or something in between?
Yes.
Well, check this guy out though, right guys? It's a quartic. It's a positive
Yeah,
quartic.
1.7 would be bigger. 1.3.
Because if you think about to the 4th power, 1.7 minus 1, wait. 4.3 minus 1, aren't they going to be the same?
Yeah.
Because it's
Yeah.
2 even power. So
Yeah.
either way doesn't matter, we just need to plug in one, sure?
True.
So we can say, cool. A sub 4 up, just plug in 1.7 unless about 0.3. We end up with 0.7 to the power of 4 over 4, which ends up equaling, no say, you're the calculator, go.
Oh.
7 to the power of 4 minus, or sorry, divided by 4.
0.060025.
0.06.
Gee.
Yeah. It might be what.
Wait a minute.
Do you do 0.7 or 1.7?
Well, it's 1.7 minus 1, right?
Oh, minus 1. Oh, yeah.
Plug in 1.
Yeah.
Plug in
Is it
2.
4 factorial or just
That's what I wanted to know.
It's just 4 because they gave us the Taylor series.
I was wondering where you got that from.
should we try 0.3?
Yeah, you could. 0.3 minus 1 would be negative 0.7, which would be the same. Maximum value of the error is the n plus first term.
Is it n plus 1? Should it be like, I don't know. Should it be, oh, we did do that.
Yeah, because it's the 3rd degree. So if you plug in 1, plug in 2, plug in 3. It'd be the 4th. Okay, so what we get? 0.0.
600. There's a
The
point.
only thing that could change this is if Lagrange is smaller. Lagrange could be smaller. This is an alternating series test. Remember that Lagrange is sometimes more precise.
Don't we need to plug in 1.7 to the ln of don't we need to solve the inequality?
Because they're asking for the whole subtraction. See it? Okay, so what will Lagrange tell us? That would tell us the 4th derivative, right? Of z all over 4 factorial times x minus 1 to the 4th. So the only answer is what if Lagrange restricts it more? So then the error is within, for sure, is within 0.0600, so we can automatically say, well, these ones, that's outside the interval, right? But the only question is, does Lagrange limit it more? What would be the fourth?
0.7 or 1.7?
Maybe, you have to think about the fourth derivative of f though. So, wait. Let's call g of x ln. They use f to talk about the polynomial approximation. Excuse me. So we have to use g to talk about. We don't want to take the fourth derivative of the polynomial. We want to take the fourth derivative of our function. Okay, what's the fourth derivative ln?
1 over x negative.
That's the
Square.
first.
Square positive 2
That's the
x to
second.
the negative 3
That's the third.
negative 6 x to the negative 4.
So we can do
Oh, wait, that's the.
negative 6 over c to the fourth all over 4 factorial times x minus 1 to the fourth. On the interval 0.3 to 1.7, what would maximize the fourth derivative?
0.3.
0.3.
Wait, is it after the value of the fourth derivative?
Why is the 0.3 not 1.7? What does it matter?
Because
Yeah, the
negative
maximized
6 over
Because
0.3 to
remember-
the fourth is
Yeah.
bigger than.
Z has to be within,
X to C.
1 is in between. Yeah, x to c, so either 1 to 1.7 or 1 to 0.3, because they haven't given us the x. So we don't know for sure, but it's one of those regions. So we're looking at z's within 0.3 to 1.7. And the smaller the denominator, the bigger the number. So you would have negative 6 divided by, which the negative doesn't really matter anymore, but either way, 0.3 to the fourth, all over 4 factorial.
Well, if you plug in 1.
What would minimize, oh, it doesn't really matter, does it? Whichever one you plug in, you're still gonna have 0.7 to the fourth. So it's 0.7 to the fourth.
Wait, Misty, since it's negative 6, would negative 6 over z to the fourth, wouldn't we want 1.7?
But it's
Because-
absolute value, right?
Oh, it is absolutely.
Yeah.
Okay, never mind.
Yeah. So that's why, sorry, I haven't dealt with it, but ultimately the 6 isn't gonna matter. Or the negative isn't gonna matter, I should say.
Sorry, I forgot about that.
No. It's a good question.
Um,
So 6 is gonna be over 0.3 to the fourth times 4 factorial times x minus 1. And ultimately, it's not gonna matter if we plug in 1.7 or 0.3. They're gonna give us the same range. What do you get, Gerardo? 0.7 to the fourth times 6 divided by 4 factorial times 0.3 to the fourth.
7.4.
7.4?
Yeah, that's what I got too. I don't really know how.
Let's look at the answer.
The answer, he just said to put it in your calculator.
Well, what is the answer? Is 18, right? 18 is C. 0.145.
What the? Do we have to subtract from
Okay, look. There's a 0.030. We got 0.060 right up front. Oh wait, answer C.
Yeah, they did the Taylor's. Who do you put as our third?
Oh, cheaters!
Did they seriously?
They literally just plugged this in minus that to the calculator and found the maximum value. It's a calculator problem, duh. We were trying to use our,
So ln of x minus the approximation? What did they put in? What did they put for where?
So they just plugged
they just plugged in the whole shabam. They did absolute value ln of x minus, and they plugged in this and this and this and this. And then they put the graphing window as 0.3 to 1.7. And the highest value was, they solved. Sorry, I forget that you're able to do that on calculator problems. So long story short, our Lagrange error bound, yeah, it's within. Our alternating series error bound, yeah, it's within. But they wanted literally the maximum, not like a bound. They wanted the actual maximum value. You guys graphing it?
We got a problem, Misty.
Why, kid?
Hold L of x minus.
You forgot
And those are the
parentheses.
No. I accounted for all of those
Oh, you
already.
did?
I switched all the signs.
Now I can correct you. All we got is a flat line. Literally, it's just
But it also, the thing is it's supposed to be like 0.145.
Did you?
So,
Oh, you have some value, did you?
no, I didn't drop the value.
Ah.
That's why.
Of
Yeah.
course. X minus and divide 600.
I just changed the one watts. Was that from 0 to 10?
And also probably why it looked really flat.
Was it over 3? I'm assuming that was a yes. I heard runs.
Yes.
Okay.
Oh.
Remember, you can do second.
Oh, that's right.
Oh. Oh, is this a
And change your y's
To what?
to something smaller because it's negative 10 to 10. So it might look. And
Oh,
since our max, why isn't it small?
I'm putting, oh, that's good. Yeah, just, I did negative 1.5 and 1.5.
I did 0 to 0.2.
Because we know it's within 0.06.
Yeah, so 0.3. 0.3 is 0.634, and 0.7 is 0.528. Huh. Well, that gives us nothing.
We have to find the in between.
In between, huh?
I'm sure to find the max value.
Yeah, but it can equal either or, and max value is 0.3, which is 0.634.
I have 0.144.
So they round. What?
Yeah. 0.145.
Oh, so
Right there. 0.145.
And what did I do wrong?
I don't know. Input something wrong probably, bud. Make sure your parentheses are okay. The
I
ln has to be minus.
alternating for the sum, for the polynomial, is that bad?
You do have to do alternating. I did as well.
I didn't. It's minus plus, right?
Check it out. Look at the problem. I think it's plus minus.
Oh, there we go.
All right. 0.145.
Yep, 1.45. Oh my goodness.
We just made it way too hard. Well, we'll just say graph. Dun 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 dun. Okay. That was fun. So Lagrange was definitely within alternating series. It does not maximize. So hence our dilemma. We could have, what could we have done alternating series? Why didn't it work?
You want to answer C?
Yeah, but I feel like alternating series should have somewhat worked as well. I might have to ponder that a little bit more.
Misty, can we go number 16 real quick? I just like a small question.
Okay. Or our last one anyway. Number 16?
Yeah.
Yeah.
How do we know sine over 2 over pi if it's less than 1?
Sine is never bigger.
That's never mind. So then 1 over 3
That works.
would be 1/3. Right?
Yeah, I think sine of 2, that'd be a sine of something in the second quadrant, but still.
Right?
Between 0 and 1. Okay, number 19.
Oh yeah, I totally forgot.
What are all the values of x for which the series converges? Hey, interval of convergence. Whew, something's a little bit more normal. Not that I'm trying to have us graph and find that.
Oh yeah. We should see.
Limit. As n goes to infinity of a to the n plus 1. easy. The n can come out. We end up with an x plus 2 left within. The limit as n goes to positive infinity, n's only positives anyway, is going to end up being 1. So we end up with x plus 2 less than 1, which leaves us to a negative 1 and positive 1, which ends up being
What? Oh, go endpoints.
Can we test? Haven't dealt with that in a while. Remember we plug in?
You can extend page down.
I know, that's nicer. So negative 1 plus 2 is 1, so we end up with
Oh,
sorry.
Oh.
1 to the n, which is just 1, right? Over n to the 1/2, which diverges by p series. We say x cannot equal negative 1, right? And if I plug in negative 3 plus 2 is negative 1 to the n. Because it's an alternating series, limit as n goes, limit of a sub n equals 0.
Conditional conversions.
So
Then we
even if
say,
it's conditionally convergent, we can still do the less than or equal to?
yes. Because at that point, because it's alternating, the conditional just says because it's alternating, basically for our purposes. You can say that's a check. And so we have x is greater than or equal to negative 3 less than negative 1 tenth or 1 tenth. Aha!
A lot easier and better.
Those are all the questions you guys had.
And see, there's one more on homework for it was
Okay.
the telescoping.
Is this 10-4 or 10-5?
10-4, number 60.
I think I got that one.
I might have been over.
Yeah, I got it. I did,
What page was 10-4 on?
521.
521?
Probably like 522 or 23.
Okay, and it was number
60.
how do we find the sum of a telescoping?
So I definitely did the
First-
N plus 1.
first term plus relative infinity of the n plus first term. Well, then again, all the terms that don't cancel out. If it depends.
Right, so which means we should probably expand it, right?
Yeah, it's I got it.
So when you plug in 1, you end up with
1/2 minus 1/5 all plus 1/5 minus 1/8 all plus 1/8 minus 1/5.
did you get partial fractions first?
Yeah, it is.
So partial fractions will split it up into the pieces, and then you're able to see
Mhm.
A cancels A, A cancels A, cancels, and we end up with final answer of 10. But you need partial fractions. You need partial fractions, otherwise it's not going to be very. You're not going to see the telescoping nature that's contained therein. All right, how's it look? Did we at least get through all the questions?
I'm stumbling on questions that I do.
Okay, so you're asking questions as they come, yeah?
Miss D, I have a problem. I did.
Pause for 1 second. So then for the rest of the class, we have like 4 minutes. If you guys want to play with an FRQ, you can play with an FRQ. If you want to keep your multiple choice out so that if someone else has a question as he goes along, you guys can be ready to answer, because then that makes you internalize the information a bit more. But otherwise, let's just work. Sound good?
I fit 10-4 all here. Do I just start 10-5 in section 3 for my?
Oh, the dilemma is that there's no more. Well, we're going to do the next one. In chapter 11.
I guess I'm gonna have to do this.
Exactly. There we go.
Just don't give us any more warm-ups.
Oh, we're not going to do that many warm-ups.
Yeah, I was gonna say warm-ups aren't gonna take that entire section.
Yeah,
So you're
We're good. We're good.
It takes
All right, kiddos, let's work a little bit. And I'll come back and play with nasty factoring and how to explain it to my algebra kids.
I'm good at factoring. I can help.
With a number in front?
Yeah.
With a
Just
negative
gotta
number in front?
No, she just got a group.
Problem is, they're struggling pulling out greatest common factors, so the grouping thing.
Well, I mean, you don't have. I mean, if they don't like that, can't you just keep going? And then, although the numbers are bigger, it still works the same. Right?
10 times 3.
But it's a lot of steps.
You show them.
That snowball.
You show them like the product of A and C, the sum of B, right? That was always easiest for me. I don't know. Maybe you might want to try that. That's why I still do it.
I only have one problem with that verse.
Is that what you're looking at algebra 1 though, or algebra 2?
Algebra 1. I learned it with Mr. Parker.
Older women, as in like,
I didn't learn the way you do it. I never
Not
learned
like
that.
I'll probably finish it the way this book teaches it, just so if they're looking at the examples, they know how to do it, and then I'll be like, hey, this might be a shortcut, but only use it if it
so
works for you, kind
technically
of
the
thing.
verse would somewhat change when you're like older.
I always thought it was longer because you do it a lot faster.
If you get good at this one, it looks longer at the beginning, but once you get good at it, you do it all in your
I
head,
feel
so
like
it
it's
gets
switched in
faster
that kind of
eventually.
context.
But right now it's longer. It starts off longer.
Right. I have to study a lot for this test.
You guys have a lot more going on tomorrow, or not too bad?
What's
I don't think too bad.
Okay.
We have 2 games today.
2 games.
Yeah, we do.
Street basketball.
But it's for a good cause.
Girls and boys.
Oh.
Yeah, that round.
That went right over my
What?
head.
I thought the boys lost.
They lost in the open division, like the CIF, which the girls just won their CIF division. We lost in ours, but then both teams are going to state. So it's
We
like a different.
chose to be in a higher division because it was like a badge of honor, but we didn't win that higher division, but just by being able to go into that higher division, you're automatically in state.
Cool.
It's kind of how that one went. It's a little complicated, but
I don't like that all the games are on Wednesdays and Saturdays, because I have youth group on Wednesdays and church on Saturdays. So I've missed like every day.
Sure, it's Saturday.
When I
Yeah,
went to college, that's what I'm
my-
gonna do. Go to church on Saturday, so I can go on Sunday.
my church Rocky Beach, they just switched because the church was growing too fast, and so they built a new room for us, but then now they're using that for like the overflow technically.
for you like youth group?
Yes, so we can't be in there now during 11 o'clock service, which is when we've always had it. So they switched us to Saturday nights because Saturday nights are smaller. So now we have that room,
You can have your room.
but it's Saturday nights.
Okay, let's get up on Sunday.
But I still do because I work in the 1-year-old room on Sundays. So I used to work
Aw.
and then go to church, but now it's church, sleep, church.
Aww, look at you.
They're adorable except they scream.
Is it? That's okay. I think the Taylor Swift like F of C and F.
Well,
Steve, will you be here?
So that's why I have to do derivative.
I mean, you can. It doesn't like it doesn't fit nicely into your pattern. That's why I like it.
plus you guys have
Because this is the shortcut version of doing this, which
Shortcut.
is functions.
Um,
But since that
Oh,
doesn't fit nicely, I would just do it.
Can I have this too?
That's what you have now.